Okay, now in this lecture we shall discuss about the blocking assignment statements, right? And before coming to the blocking assignment statements, I will just recall you about the procedural assignment statement, and then I will explain about the examples of the blocking statements. Now, already we know about these procedural assignments. There are basically two procedural blocks. One is initial block and another is always block. Now, procedural assignments can only appear inside procedural blocks, initial and always. So we have already done a lot of Verilog modules in which we have used always block while writing the behavior model of any Verilog module, and initial block we have used when we write the test bench. Initial block execute only once, whereas always block executes continuously. Now the left hand side of procedural statement should be a register type. We know there are four register types, and these are rig type, integer type, real type and time type. So left hand side of the procedural statement. So suppose there is some procedural statement. This is your right hand side expression, and this is our left hand side target signal. So this left hand side, it must be a register type. The right hand side expression can be of net type or register type variables. So in the right hand side expression we can use net type or register type. Now there are two types of procedural assignments, right? One is blocking type of procedural assignment, and it is denoted by equal to symbol. We have done a lot of examples by using blocking type procedural assignments. And there is another type of procedural assignment, and that is non-blocking, and it is denoted by this assignment symbol, less than equal to, right? So first we will see in this lecture about the blocking assignment. So general syntax of the blocking assignment is variable name. This is the assignment symbol of the blocking assignment statement. Then delay or event control, this is optional, and then we can write the expression, right? Here this equal to symbol is used to specify blocking statement. For example, Z is equal to A ampersand B, right? This is B. So here this symbol indicates this is a blocking procedural statement, and you can find this statement inside always block or inside initial block. So here this is the right hand side expression, and here in this right hand side expression these A and B can be net type or register type, whereas this is left hand side expression, and this Z which is in the left hand side, this can be only register type. So in most of the cases we have used this Z as a rig type, right? So rig type is most commonly used, and here we can use the optional delay like this. Hash, suppose we have written hash 5. So what will happen? A and B, this will be evaluated, and after 5 unit time, it will be assigned to Z, right? So now the blocking assignment statements executes in the order they are written inside a procedural block, right? So the meaning is, suppose there are statements like Z is equal to A ampersand B, Y is equal to X ampersand C. So, and these statements are appearing inside some always block. Always block, right? So now what will happen? These statements, these are your procedural statements, which you can find inside always block or initial block. So these statements, how they are appeared in the same order, they will be executed. Now the target of the assignment is updated before the execution of the next statement in the procedural block. So the meaning is this: suppose this is the statement number 1 and this is the statement number 2. So in case of this blocking statement, first statement 1 is executed, then the target signal is here Z. This target signal will be updated only after the updation of the target signal. The second statement will be executed. So this means the statement number 1 is blocking the statement number 2. Unless statement number 1 is executed and the target signal is updated, statement number 2 will not execute. So this is the meaning of blocking statement, right? So it blocks all the other statements which are appearing after this particular statement, right? So the target of the assignment is updated before the execution of the next statement in the procedural block, right? They do not block the execution of statements in other procedural block. So the meaning is this: suppose this is one always statement and there is another always statement, is the always block is there, right? And inside the always block, this always block, there are few statements. So here in this case, the statement number 1 will not block the statements of other procedural block, right? It will block the execution of the statements in the same block, right? Okay. So the blocking statement means it will block the execution of the other subsequent statements. Unless the statement 1 is executed, statement 2 will not execute. And unless the statement 2 is executed, if suppose there is another statement number 3, then statement number 3 will be executed only after the execution of the statement 2 and the updation of the value of target signal Y. After this only statement 3 will be executed. So here the statements are blocking the subsequent statements. Okay. Now this is the recommended style for modeling combinational logic. So basically we use the blocking assignment statement for the modeling of the combinational circuit. But it is also possible to use the blocking statement for the modeling of the sequential circuit. That is also possible. But generally for the combinational logic modeling, we use the blocking statements. Now blocking statements can also generate sequential circuits if all the values of the case expression is not used in the program. So already we have seen many case statements, right? Programs. And if you recall, in the last we use this default and some expression, right? So with this default, what will happen? All the unassigned values in the case expression will be covered by the default clause, right? So in this case, the default clause will use will cover all the values of the case expression, right? But suppose if we have not used this default clause, then what will happen? Then blocking statement, then in that case, the blocking statement can generate the sequential circuit also, right? That's why it is recommended that if you are modeling the combinational circuit by using case statement, then in the last we shall use the default statement. Okay. Okay, now we will see one example of the blocking statement. Blocking statement example number 1. So here we have written one code. Here A, B, C are declared as the integer type, and here we are using the initial block, right? For a better understanding of this blocking statement, we are using initial block, then begin and end. Because in between begin and end, there are multiple statements. That's why we are using begin end. If there is only one statement, then there is no need of begin and end. So here the first statement is A is equal to 10. So 10 will be assigned to A. The second statement is B is equal to B. 20. B is equal to 20. 20 is assigned to B. The third statement is C is equal to 15. 15 is assigned to C. And the fourth statement is A is equal to B plus C. Fifth statement is B is equal to A plus 5. And sixth statement is C is equal to A minus B. So here, since we are using this equal to symbol, this implies that this is a blocking assignment statements. Okay, now what we will see here, the initial values of A is 1. This initial value of A is 10, B is 20, and C is 15 due to three statements. Statement number 1, statement number 2, and statement number 3. The value of A will be assigned, will get a value, the A will get a value 10, B will get a value 20, and C will get a value 15. Right. Now, when the fourth statement is executed, so what it will do? A is equal to B plus C. So since B is 20 and C is 15, so this fourth statement will evaluate B plus C. The result is 20, result is 35, and 35 will be assigned to A. So A will become 35. Now unless fourth statement is executed, fifth will not execute. So when the fifth statement is executed, at that time this A, here you will get the updated value of A from the statement number 4, right? So now here what we have, A plus 5. A is already updated. A is 35. So 5 will be added in that. So A plus 5 will be 40, and 40 will be assigned to B. Now when the fifth statement is executed completely and B is updated, then only statement number 6 will be executed. So now B is 40, and in statement number 6, C is equal to A minus B. So the answer will be minus 5, and minus 5 will be allocated to C, right? So this is the process of the execution of blocking assignment statement. Now after the simulation of this particular code, we got this result. So now here you can see finally what is the value of A. A is 35. So you can see here, already I told you earlier classes, in earlier lectures, these A, B, C, which are declared as integers. So for an integer, 32 bits will be assigned for the integer value, right? So by default, 32 bits will be assigned for integer value, right? So now here you can find here, these are the 32 bits, right, for A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and next for is 32. So total 32 bits are assigned for the integer. So the value of the integer is 35. So see here what is mentioned here. In lower bits, these bits, you see what is written here. It is 1 0 0 0 1 1 and all zeros, so in total these are 32 bits, right? So what is the decimal equivalent of this binary? So the weightage of this is 32. The weight of this one is 2 and the weight of this one is 1. So this value represents 35. This value represents 35. Now for B, right? So this is B. Now for B, what value is assigned here? 1 0 1 0 0 1 0 1 0 0, right? And here all zeros up to 32 bits. So what this represents? So here the weight for this one is 8 and the weight for this one is 32. So 32 plus 8. So this binary value 1 0 1 0 0 0, it represents 40, which is the value of this B. And then for C it is minus 5. Minus 5 is represented in one's complement method. Okay, so here one's complement, see here, see this MSB. This MSB is 1, right? We know that in signed number, these all the numbers are represented in signed value. So the MSB 0, this MSB 0, this MSB 0 indicates that number is positive, and this 1 at the MSB, this indicate number is negative, right? And the number is represented in sign one's complement method. So in one's complement method, whatever is written here, if you convert this in 2's complement form, it is represented. If you convert this result in 2's complement form, you will get 5, right? For example, you convert this in one's complement form. So here it will be 0 0 1, then 0 0 all 0. This is the one's complement, and convert it in 2's complement. So for that you add 1 in this, then you will get the 2's complement. So what is the answer? 1 0 1, then all zeros, 0 0 0. So what is the decimal value of this, decimal equivalent of this? So this is equivalent to, the weight of this one is 1 and the weight of this one is 4. So 1 plus 4, and this is equal to 5, right? And put minus sign. So this here, this is representing minus 5. So always remember, minus value is represented in 2's complement form, right? By seeing the MSB of the result, you can identify whether the number is positive or negative. If at the MSB you are getting 0, so number is positive. If at the MSB you are getting 1, this means number is uh, negative. And to find out what is the value of this number, you convert this whole number into complement form. Then whatever you will get, you put one minus sign in front of this, and that will be the value of this number. So in this way, we got this result of this particular code. Now we see another example. So here again A, B, C are the integers. A will become 10, B will be 20, and C will be 15. Then A is equal to B plus C, B is equal to A plus 5, and C is equal to B minus A. In earlier case, only one change I have made. Here it is A minus B, right? That's why we were getting the result this minus 5. A minus B means 35 minus 40. But there everything is same in this code. Only thing is here last statement is B minus C. So with this you will get this result, right? A will remain 35, B will remain 40, and now C will be plus 5. So if you see the result here, this is same 35, this is A, right? This is B and 40, and in C, in the last C, this is the value of C. See the MSB. MSB is 0. So what is the meaning of this 0? That number is positive. And what is the number? You write the decimal equivalent of this binary value. So it is 5. So we are getting this 5 result. Okay. We see another example, number 3. Here A is 10, B will become 20, and C will become 15. Then A is equal to B plus C. B plus C means 35. A will become 35. Now once this statement is executed, after this only this statement is executed, but here you see what we have written. B is equal to hash 5 A plus 5. So the meaning of this statement is A plus 5. A has become 35 due to this statement. So 35 plus 5 will be 40. So B will become 40 after 5 unit time of the execution of previous statement, right? So previous statement executed at t is equal to 0, right? At that simulation time t is equal to 0. So the value B means this target signal B will get the value after 5 unit time of the execution of previous statement. So this will be the result. This A becomes 35 at the start of the simulation. It will become 35 at the start of the simulation because here in this statement no time delay is mentioned, right? That's why all this updation will take place at the same time. Now B becomes 40 at 5 unit time of simulation. We see this result. See here A. This is the value of A, which is 35. Now see the value of B. Okay, this line shows 5 nanosecond. 5 nanosecond, and here this is 0 nanosecond. 0 nanoseconds. So value of A will become 35 at this time itself, at 0 nanosecond itself, right? But the value of, now you see, before this is 5 nanosecond, before 5 nanosecond, what is the value of B? It is 1 0 1 0 0 1 0 1 0 0, and here all 0. So what is this value? if you write in decimal, then it will be 16 plus 8. It will be 20. So value of B is 20. Up to 5ns, the value of B is 20. Because you see here, this statement, B is 20. B will become 20 exactly at 0 nanosecond. At this time, B will become 20. And it will remain 20. The next change in the value of B will be after 5 unit time of the start of the simulation. Right? So that's why at 5 ns, after 5 ns, this is the value of B. This is the value of B. You find what is this value? See here 1 0 1 0 0 1 0 1 0 0 0 and all zeros here. So if you write in decimal equivalent of this, then it will be 8. 8 is the weight of this one, plus this is 32. 32 plus 8. So 32 plus 8 is 40. Right? So the value of B will become 40 at 5 ns. Right? So here this timing is optional. You can mention this optional time. Right? So this 5 ns means after this execution of this statement, you wait for 5 ns, then only update the value to target signal B. Okay. So in this way, we can say that a blocking statement blocks the execution of the subsequent statements. Okay. And when the target signal of any statement will be updated, only after that the next statement will be executed. Right. Now in next lecture we will discuss about non-blocking assignment statement. Then you will understand exactly how this blocking and non-blocking statements differs. Okay.